Good morning, our listeners. Welcome on our video today. As you can see, we have a paper here. This is chemistry. This is form 1 work. This is a complete paper. We have questions and answers here, and you can see it is out of 100. You can see these are the questions that we are talking about. We have very many of them here, which we are going to discuss right away. And we request you to watch this video up to the end so that you can benefit out of this work. If this is your first time to watch our videos, kindly consider subscribing to this channel so that you can benefit out of the work that we do. In this channel we have very many videos, revision videos, KCSE or subjects, and we have also dealt with set books, that is the new set books, like now the Fathers of Nations, Guza Jadi, Bebaya Maisha, and all other set books. We have dealt with them on this channel, so anytime you want to do revision, you can come on this channel. To the subscribers, we want to thank you guys for the support that you've awarded us. It is because of your support that this channel has grown this far. Let's go to the work. You are told number 1, the curves below represent the variation of temperature with time when pure and impure sample of solid were heated separately. So you can see temperature, you can see time. We have curve A and curve B, and you can see how they are behaving when the temperature when the temperature increases, what happens. So you are told which curve shows the variation in temperature for a pure solid. Explain which one is pure solid between A and B. That one is curve B. Why? It has a sharp melting point, as you can see, and that is B has a very sharp melting point and boiling point. That is the answer. Question number 2, state the effect of an impurity on the melting and boiling point of a pure substance. The effect of an impurity on the melting and boiling point of a pure substance. Impurities lower the melting point of a pure substance, while impurities raises the boiling point of a pure substance. Question number 2, what is a saturated solution? What is a saturated solution? A solution that cannot dissolve any more solutes at a given temperature. So that is what we call a saturated solution. B, state 2 implications of crystallization. Two applications of crystallization. That one is extraction of salt from salt water. Number 2, extraction of sugar from sugar cane. Number 3, extraction of medicinal substance from plants. That is where we can apply that method of crystallization. Question number 3, the setup below was used to study some properties of air. You can see here, you can see water, beaker, and then test tube, then moist iron fillings. And you are told, why were iron fillings moistened? Why were they moistened? To enable them stick in on the test tube. That is why they were wasted. Number 2, state and explain 2 observations that would be made at the end of experiment. What observation was made at the end of this experiment? And the observation is iron fillings turned brown due to rusting. Water levels rose up in the test tube. 2, occupy the space initially occupied by used oxygen. So that is what happened at the end of the experiment. Question number 3, you are told a Form 2 student, in an attempt to stop rusting, put copper and zinc in contact with iron as shown in the diagram below. You can see copper here, and then you can see zinc, iron. So you are told state whether rusting occurred after 1 week if the setups were left outside. You state whether it happened. Experiment Roman 1, rusting occurred, and then Roman 2, no rusting. Explain your answer. You are told to explain why rusting occurred on Roman 1 and not in experiment Roman 2. Iron more reactive than copper, hence undergoes reaction with air and moisture. Zinc more reactive than iron, hence undergoes corrosion in place of iron. Let's go to question number 5. This one is an experiment. You can see this setup, very common. These are questions that they usually repeat in most of exams, even KCSE. So you are told a student left some crushed fruit mixture with water for some days. He found the mixture and fermented. He concluded that the mixture was contaminated with water and ethanol with boiling point of 100 C centigrade and 78 degrees Celsius respectively. The setup of apparatus below are used to separate the mixture. So we have a thermometer, we have a mixture, that mixture that he left there. Then we have apparatus debris, we have point B, point A, we have conical flask, we have distillate. So, and then we have a source of heat. So you are told to name the piece of apparatus labeled debris. What apparatus is that one? That one is Liebig condenser. This one, very common question. What was the purpose of the thermometer in the setup? You can see the thermometer is here. Why was it used? It was used to indicate when a liquid is boiling. A thermometer reads a constant temperature to determine the fraction coming out. The purpose of that was to, first of all, to indicate when a liquid is boiling. The thermometer read a constant temperature. Then number 2, to determine the fraction coming out. Then next, at which end of the apparatus debris should tap water be connected? At what end or at what point? It should be connected at point A. Water should be connected at A. Why? Because now the water is used to cool down the substance. Next, you are told which liquid was collected at the first distillate. Explain. The first distillate was ethanol. Why? It has a lower boiling point of 78 Celsius. Then compared to water, with a boiling point of 100 C, or the liquid with the lower boiling point boils fast and its vapors are condensed, and the condenser to be collected as the first distillate. Then we go to the next question. I told, what is the name given to the above method of separating mixture? That one is fractional distillation. And by next, you are told, state 2 applications of the above method of separating mixture. What two applications? Where can it be applied? It can be applied to separate components of crude oil. It can be applied to isolate oxygen gas and nitrogen gas from air. It can also be used to manufacture spirits. Next, what properties of the mixture make it possible for the component to be separated by the above method? They are immiscible liquid. You can also say they have different but close boiling points. Next, study the diagram below and answer the questions that follow. We have a diagram here. Number 6, we have a diagram here. We have wire gas, then we have heat being applied, then we have cold water, we have a mixture of iodine and sodium chloride. You are told, state and explain the observation to be made. State and explain the observation to be made on that experiment where we have the mixture of iodine and sodium chloride, and then cold water at the top. And then the answer is the purple color is deposited at the bottom of the crucible due to iodine subliming. White solid of sodium chloride remains in the beaker because it does not sublime. That is the observation made. What is the purpose of the cold water in this setup? To cool iodine vapor to iodine solid. Next, number 7, we have another diagram here, and you are told the diagram below is set up for the laboratory separation of oxygen gas. So we have hydrogen peroxide, then we have gas X, you can see we have water, then we have solid R. You are told to name solid R. That one is manganese 4 oxide. You are told to write an equation for the reaction that takes place in the flask. What reaction? So we have hydrogen peroxide and water. When you heat hydrogen peroxide, it gives water and oxygen. That's why you can see gas X being collected there. Complete the setup on to show how oxygen gas is collected on the diagram. So you can see that one. You can complete. This experiment was not complete. It was drawn up to the point where you can see the difference. So you're supposed to complete, and this one is something you need to cram because they bring one part and tell you to complete the experiment. Number D, you're told state the physical properties of oxygen gas which is considered when choosing the method of gas collection in the above. Why do we use that method? That one, oxygen gas slightly soluble in water. E, you are told name another setup of a liquid and a solid that can be used to prepare oxygen gas. That one is liquid water, and solid it can be sodium peroxide. Number F, give two commercial uses of oxygen. This one is also common. Oxygen is used for flame, for welding, also used as a rocket fuel. It is also used for breathing aid in hospitals. Next, it is used for steel making. Next, it is used in deep sea diving. Number 8, we are going to answer number 8. The samples of equal volumes of water were put in 100 centimeters cubed conical flask and heated for 5 minutes on Bunsen burner. It was observed that sample 1 registered a low temperature than sample 2. Now you can see sample 1 and sample 2, flame 1, flame 2. You can see them here. Name flame 1. Flame 1 is luminous flame. Next, stage 1 disadvantages of using flame 1 for heating. It is luminous flame, as we know it is less hot, produce soot. Next, number 9, you are told study the table below which shows the pH value of solution A, B, C, D, and E. Use it to answer the questions that follow. Solution A, pH is 13, B, pH is 7, C, pH is 9, D, pH is 6.5, E, pH is 2.0. You are told which solution is the most acidic. That one is E. pH value is very low. Then which solution is a neutral? That one is B. Then you are told to identify the solution that is most likely to be rainwater. That one is D. A solution that is most likely to be antacid tablet. That one is C. Then a solution that is likely to be sodium hydroxide. That one is A. We go to the next question, number 10. Student accidentally mixed potassium chloride with white sand in the laboratory. Briefly describe how the mixture can be separated. How to separate a mixture of potassium chloride and a sand. Add water to the mixture to dissolve sodium chloride. Filter to obtain sand as a residue and potassium chloride as filtrate. Evaporate the filtrate to obtain crystals of potassium chloride. Number 11. You are told metal S removes oxygen combined with P and Q. Metal S removes oxygen combined with P. Q reacts with the oxide of R and not with oxide of P. P reacts with cold water, but Q does not. Which is the most reactive metal? That one is S. Which is the least reactive metal? That is R. Arrange the metals in order of reactivity, starting with the most reactive to the least reactive. So arranging them according to order of reactivity. So R, Q, P, S. Number 12. What are the 2 causes of accident in laboratory? What causes accident in a laboratory? Number 1 is ignorance. Number 2 is carelessness. Next, you are told a Form 1 student accidentally touches a colorless liquid which poured on the laboratory bench during a chemistry lesson. He suspected that liquid to be water. Briefly explain what he is supposed to do. Rinse area that affected immediately with a lot of clean water, or report to the teacher or laboratory technician. We go to question number 13. You are told a wooden splint slipped into the outermost and the innermost regions of the noisy flame produced by a Bunsen burner. Draw diagram to show how the wooden splints were affected when placed in both regions. So the first thing to know is that this one is a noisy what? It's a noisy flame. So middle part of that stick, and then the middle, and then the outer part. You are told what conclusion can be made from the experiment. What can you conclude? The outermost zone in an luminous flame is hotter than the inner zone. Describe how oil can be obtained from a coconut. This one is also a very common question. Crush the coconut using a mortar and pestle and propanol. While crushing, decant filter. Place the extract under sunlight on an evaporating dish. Number 15. Flour extracts can also be called a simple acid base indicator. You are told what is an indicator. An indicator is a substance that shows distinct colors in acidic and basic solutions. So that is what we call indicator. Number 2, or number B, 15B, state advantages of using universal indicator over simple acid base indicator. Universal indicator can be used to obtain the strength of an acid or basic solution. Universal indicator shows consistent results. Question number 16. We are going on properly. We are almost done. Don't be tired. Question number 16. A Form 4 student heated a dark purple solid in a test tube and a colorless gas which relighted and glowing splints formed. Suggest the possible identity of the colorless gas. That one is oxygen. B. Name a suitable drying agent that could be used to dry the colorless gas. Name a suitable drying agent can be used to dry the colorless gas. That one is concentrated sulfuric acid or anhydrous calcium chloride. Next, we go to question number 17. Both phosphorus and magnesium produce two white compounds when heated in air separately. Write two words equations to show reaction that occur when phosphorus burn in air. Write two word equation to show reactions that occur when phosphorus burn in air. So phosphorus, you burn it in oxygen, you get phosphorus 5 oxide. Phosphorus plus oxygen, you get phosphorus 3 oxide. Next, write two word equation to show the reaction that occur when magnesium burn in air. And these are simple reactions or simple questions. Magnesium plus oxygen, you get magnesium oxide. Magnesium plus nitrogen, you get magnesium nitrate. Next, you are to describe an experiment you would carry out to distinguish the white solid formed by magnesium from that formed by phosphorus after burning this element in air separately. So you are to describe an experiment you would carry out to distinguish the white solid formed by magnesium from that formed by phosphorus after burning this element in air separately. So what you do to differentiate: dissolve one of the solid in water, place both red and blue litmus paper in the solution formed. Repeat the procedure using the second solid. The product form from magnesium turn a red litmus paper blue and has no effect on the blue litmus paper, while the product from phosphorus turn a blue litmus paper red and has no effect on the red litmus paper. And then that is how you mark that. Question number 18. When a student was stung by a nettle plant, a teacher applying an aqueous solution of ammonia to the affected area of the skin, and the student was relieved of the pain. Explain. The product from the nettle plant is acidic, hence aqueous ammonia solution being basic neutralizes the acidic product. Next, you're told a farmer intended to plant cabbages in his farm. He first tested the pH of the soil and found it to be 3.0. If cabbages do well in alkaline solution or alkaline soil, explain advice that would be given to the farmer in order to realize the high yield. Apply calcium oxide. This one is to raise the pH of the soil. And next, we go to number 20. Number 20. The diagram below represent a paper chromatogram for 3 brands of juices suspected to contain banned food coloring. So we have them here. We have substance K, L, and M. This one is solvent front. Then you're told the result showed the presence of banned food coloring in L and M. L and M. Circle the spot which show them banned food coloring. You can see them here. The coloring is being circled here. We have circled them here. You can see. Then show the solvent front. It is there. We have identified it there. Number 21. You are to define the following. Element. What is an element? An element is a pure substance which cannot be split into simpler substance by chemical means. B. What is an atom? An atom is the smallest particle of an element which can take part in a chemical change. Question number 22. You are to state and explain the observation made when zinc carbonate is added to dilute hydrochloric acid. State and explain the observation made when zinc carbonate is added to dilute hydrochloric acid. What happened is that we have effervescence due to production of carbon for gas. Number 22b, you are to write a one equation for the reaction that occur between the zinc carbonate and hydrochloric acid. So zinc carbonate, you add hydrochloric acid, you get zinc chloride, carbon dioxide, and water. Question number 23. We're almost done. Remember, it is out of 100 marks. You are told name the element present in the following compound: sodium bromide, that one is sodium bromine; zinc sulfate, that one is zinc sulfur oxygen. Then question number 24, you are told give an example: a compound that undergoes a temporary chemical change. That one is hydrated copper 2 sulfate or anhydrous copper 2 sulfate. Then hydrated cobalt 2 chloride, it is also called anhydrous copper 2 chloride. 24b, you are told state one laboratory use of the compound named in A above. That one is used for chemical test for water. Next, number 25 and the last, state 2 reasons why dry ice is preferred over ordinary ice by ice creamers vendor. Why do they prefer dry ice than the ice cream? That one, it sublimes, leaning on wetness, leaning no wetness. Then it is a better coolant. We are through with our video today. We thank you so much for watching, and we remind you, if you have not yet subscribed to our channel, kindly take 2 seconds, subscribe to this channel, like this video, and hit the bell icon so that whenever we produce a video like this one and upload in the YouTube, you will automatically be notified. Also, you can share this video with the subscribers and people who watch our videos up to the end. We thank you so much, because this channel has grown so much because of the support that you give us. Until next time, goodbye for now.